your homework. Make sure that you do all the homework problems that I have supplied. Let's look at another problem. A harmonic wave on a string with a mass per unit length of 0.05 kilogram per meter and a tension of 80 Newton has an amplitude of 5 centimeter. Each section of the string moves with simple harmonic motion at a frequency of 10 Hertz. Each section of the string moves up and down with a frequency of 10 Hertz. Find the power propagated along the string. Now, is there anybody who remembers that equation for the power propagated along a stretched string that we developed? Power 1/2 mu omega squared a squared v. Is that right? Well, I hope so. Okay, let's pick our data. We got the mass per unit length is 0.05 kilogram per meter. The tension is 80 Newton. Amplitude of vibration is 0.05 meter. And the frequency of each segment is 10 Hertz. Well, if you now look at these, can we obtain everything that we need? The power transmitted is 1/2 mu is there. Omega squared. Omega can be obtained from the frequency. Now, what is the relation between omega and the frequency f? Omega equal to 2 pi f. Alright, omega squared, a squared, you know a, times v, the speed. We now need to find the speed. Now, how do we find the speed of transverse wave on the string? If you know the tension and you know the mass per unit length, you can calculate the speed. Now look at that, we can find all those quantities. The power propagated along a stretched string is given by P equal to 1/2 mu a squared omega squared v. And of course we have mu, we have a, we have omega, how? Omega equal to 2 pi f. And we have v, how? Because we know t and mu. So first let's obtain v. V equal to square root of t over mu. That will be square root of 80 Newton divided by 0.05 kilogram per meter. Alright, calculate that on your own and see whether you get my value. I got it as 40 meter per second. Alright, please check it. Okay, omega equal to 2 pi f, f equal to 10 Hertz. That would be 2 pi multiplied by 10 Hertz. That is 20 pi Hertz. You can leave it in terms of pi. Alright, now let's bring all these quantities together. You know mu, we know a, we have now obtained the value of omega, we know the value of v, put it all together, and that will be P equal to 1/2 mu a squared omega squared v, replaced with their values, and I got it as 9.87 watt is the power transmitted along the length of that string. Now remember, wave motion is a mode of energy transfer. So how much energy is transmitted along the wave is an important concept. What is the rate at which this energy is transmitted? The rate at which the energy is transmitted is what we call power transmitted. Alright, let's try another one. Waves of frequency 200 Hertz and amplitude 1.2 centimeter move along a 20 centimeter string that has a mass of 0.6 kilogram and a tension of 50 Newton. What is the average total energy of the waves on the string? What is the average energy transmitted along the string? What's the equation for energy transmitted? Well, 1/2 mu omega squared a squared delta x, which can be replaced by V times T. And then finally, what is the power transmitted past a given point on the string? Alright, the first thing we need to do is to pick our data. What are the given data we have? M, the mass is 0.06 kilogram. The tension is 50 Newton. Amplitude of vibration is 0.012 meter. The frequency is 200 Hertz. And delta x, the length of the string, is 20 meter. So you can see what good does this do, picking up all the data. Okay, now delta E, the energy transmitted, is 1/2 mu a squared omega squared delta x. Alright, what do we have? Mu. You have the length, you have the mass of the string, you have the length of the string. Can you calculate mu? Mu is mass divided by the length. The amplitude is given to us. Omega can be calculated from the frequency value, and delta x is given to us. So let's get these values. Mu equal to m over delta x, mass per unit length. That will be 0.06 kilogram times 20 meter. That is 0.003 kilogram per meter. And that is our mu. So we got the value of mu. Omega equal to 2 pi f. F is 200 Hertz. That will be 2 pi times 200 Hertz. That will be 400 pi Hertz. I think we have now all those values. Therefore, delta E is 1/2 mu, we pick that value, times a squared, amplitude squared, times omega squared. Omega is 400 pi, and square it. Look at the way I have squared it. The quantity 400 pi. So when you put that in the calculator, take care. Put that 400 pi inside the parenthesis and square it. Multiply by 20. And I got it as 6.82 joules as the average energy transmitted along the length of the string. Alright, what do we now need? We need to find the power transmitted past a given point, the rate at which the energy is transmitted. Now, how will you get that? Well, the power, if you can look at this, the power will be 1/2 mu a squared omega squared v. So we need the value of v, the speed. Alright, let's do that in the next slide. V equal to square root of t over mu, and that will be square root of 50 Newton divided by mu is 0.003 kilogram per meter, and that will be 129.1 meter per second. I have V, I have omega, I have A, I have mu. All those values that I need are present here. Let's use it to find the power. Power is 1/2 mu a squared omega squared v, and that will be, put all those values. Mu is 0.003, amplitude is 0.012 meter, omega is 400 pi times v, the speed is 129.1 meter per second. And what does that give you? 44 watt. Okay, I think we did a number of problems, and these are representative problems that you must be familiar with. Alright, I'm going to stop this lesson here, and in the next lesson we are going to develop further on the study of waves. If you remember, I used a term in this problem, harmonic wave. What is a harmonic wave? A harmonic wave is a wave generated due to the simple harmonic vibrations of the particles. Alright, so we are going to use the equation of a simple harmonic vibration to study harmonic waves in our next lesson. Alright, I'll see you for the next lesson a little later.